Understanding kinematic equations. Kinematic equation is a very basic subject that every student in physics need to understand, because this will be repeatedly used in rest of the topics in physics. But the beginning student generally has some confusion with respect to the considering these physical quantities as vectors. So I'll just try to give some examples which perhaps would clarify to the student how to approach a kinematics problem. So, for example, let us take one problem where we are just throwing an object up and falls down, and the question is what is the time for it to go up and come down, which is generally called time of flight. So one approach which is taken is that suppose it starts with velocity v, there is a given velocity, this is the quantity which is given, that is an object is thrown with the velocity v up, then what is the time it takes for it to come back. Then we know the acceleration gravity is g, then we take the final velocity is 0, then the final velocity is equal to initial velocity v, then because acceleration is minus and the velocity is positive, so it is this direction. When we take up as positive, down as negative, so this is v minus gt. At the last coefficient is 0, so we get v is equal to gt, then t is v by g, and then we argue that the time for falling is same as the time for going up, then we will say the time of flight is 2v by g. Now, suppose we can consider the equation for displacement. Here we can see the displacement is 0. So the equation for displacement, delta x is equal to initial velocity. And then we have this equation for displacement. So we can put displacement is 0. So we get straight away, the t cancels with this. Then we get the time of flight is nothing but 2vbj. So you can see the difference in the two approaches. So only thing is one needs to understand that the displacement is a vector, and here the displacement is 0. I'll give one more example to further clarify. Suppose we are having an object thrown from a height h. This is thrown with velocity v. And we have the same problem that we need to find out the time by the time it comes here. So here we can take number one, first approach. This we can take as time of flight, this we take as a basis, then we get t1 for going up and coming down is 2v by g. Then we calculate this t2 from the equation. Now here, by the time it comes back, it will have the same velocity v, and v is now direction is changed, it is going down, g is down. Then we will have the equation s is equal to vt plus of gt square, that is this t2 quantity. So this we can, s is given as h, so we can solve this and get what is the value of t by solving this equation. And another approach, so this will get h. So another simpler approach is to take, because a vector, so minus h, because the object is starting from here, it is going down, the displacement is minus h, because the starting position is 0, the final position is h, so that is, it is minus 0 minus that is a displacement minus h. Okay. So this is equal to, we can write vt, because here the starting is going up, minus of gt square. So we can solve this equation and get the time for this total time. It is not this, because we are taking minus h, we will get that is t1 and t2 both. This time and this time both will be given by this equation. So this is another approach. I will discuss another idea, that is, suppose, no, same problem, but I'll look at it in a different way. Suppose we have a problem in which u is given, that is initial velocity, v is given, acceleration is given, and the a displacement is given, then we have to find time. So we can use the equation S delta x, or S, for example, there's a displacement is equal to V of t plus or minus whatever it is depending on the direction. So solution of this equation will give us the time. But here this is a quadratic equation. So we can do this, but quadratic equation is slightly more involved. So instead what we could do is we can do this. V final square minus V square, because this initial is equal to 2AS. So from this we get Vf square, and once we get Vf minus V by t, A is T. So we get T. So here we are avoiding, because this taking the square root of this is simple. So we are avoiding a solution for a quadratic equation. So this is another way that we can get the solution. That is the time for an object to travel a particular distance, provided this the velocity is this, acceleration time. So we can get T. So the same problem can be solved in a different way. So one can choose whatever is the fastest one, and whatever strikes one's mind, of course. So hope this helps the beginning students about solving kinematic equations. So the important point is this, that is this, all the kinematic equations are vector equations, they are not scalar equations. That's what often one uh, doesn't take into consideration. So that this example gives some clarity on how to apply the vector concept in the kinematic equations.